So we are completely back on time on the second, and I think we should go on further. Next, we welcome a true Ceph veteran and community pioneer, Wido den Hollander, CTO at Your.Online, has been part of the Ceph community for over 15 years and has developed many features himself. His presentation is a direct challenge to traditional thinking. He claims it's all about the latency, not the bandwidth. Learn why we are wrong to hyper-focus on bandwidth and storage and why you should focus only on latency. Get ready for a controversial and high educational session. Please welcome, and his name is programmed from Venlo, Netherlands, Wido den Hollander.
Good afternoon. Indeed, we're going to talk about latency. But let's start with about myself first. A short introduction. Indeed, I've been working with Ceph for quite a while now. Back in 2008, it was my first encounter with a tarball somewhere on the internet where Sage Whale, he developed something called Ceph. And I thought, oh, this is quite interesting. And I started compiling and started running it. And ever since, techie, it doesn't. On my laptop, it switches. There's some latency. Some latency indeed, yeah.
Wido, be honest, you just did it because of this latency joke, isn't it?
No. But let's put it that way. It's a latency joke. Okay, yeah. So indeed, born and live in the Netherlands. I've been working with Ceph since 2008. I used to be a Ceph trainer and consultant. I founded the company 42On, which might be familiar to a few of you. You might still be a customer of them, I don't know. So I traveled around the world to do a lot of training and consulting for Ceph. I'm an IPv6 fanatic, and I also am active in the Apache Cloud Stack community, where I wrote the Ceph integration many years ago. And my daily work, I'm CTO at Your.Online. I am a strategic CTO. I do oversee our companies because Your.Online is an investment firm. We have acquired quite a lot of hosting companies throughout Europe and nowadays also North America and expanding into markets like Asia. But one of the common things for our companies is that they use Ceph. And we see a lot of Ceph running within our companies, smaller deployments, larger deployments. Some of them are multi-petabytes in size, others are smaller in size. And I do assist our companies with their Ceph deployments. But it has been a long time since I touched the CLI of a production Ceph environment. It has been a few years now. But then we talk about bandwidth. Can anybody explain what bandwidth is? Oh, I asked. Yeah, so I asked Google and I got an AI response because that's what you do nowadays, right? You type something in Google, you get an AI response. So the maximum amount of data that can be transmitted over an internet connection within a period of time. You could say it's a highway. You just add more lanes. And then, well, you have more bandwidth, just more cars driving over the highway and you get more bandwidth. And if you add more, well, you just add more lanes, right? Because that's what they do in the US. Just one more lane, just one more lane, just one more lane. And then you end up with something like this. Just one more lane, and there's still traffic. So you can add more lanes, but you will not get to your destination any faster. So more cars can drive on the same road. They can cover the same, more cars can cover the same distance in that period of time. But if you obey the speed limit, and well, we have a speed limit here in the universe, the speed of light. Well, if you obey that speed limit, then the throughput will go up on the highway, but the time it takes for an individual car to go from A to B will still be the same. So are you still sure you want this? Everybody talks about bandwidth. Any benchmarks I see out there is always about bandwidth. I just got a few pictures from Google Images, so better, higher is better, megabytes per second, throughput. I found a Ceph Reef benchmark somewhere, gigabytes per second. That's all great, but what does it really tell you? What does a gigabyte per second tell you? Well, often it doesn't tell you a lot. It's cool to brag about. There's also this test where we achieved a terabyte per second with Ceph, which is a great result. But what in practice does it really tell you for your application? Because yes, bandwidth matters, but it's not the most important thing. And of course, you know where we're working towards because you know what the title of the presentation is. But I think you should focus on something else. You should properly understand where you need bandwidth and where you need latency. Because bandwidth is just picking up a big box and just bringing it from A to B. So I have a stack of papers here, and let's say that each individual paper is a file or an object. I just pick up the box and I walk somewhere else, and I drop it. Bandwidth, well, I just moved how many files per second? I don't know. Let's say 100 files per second to a different location. That's pretty easy, just picking up a box. Let's say you have a big warehouse and you just pick up the boxes with some trucks and move them somewhere else. But now I think that latency is far more important because time is the ultimate currency we have on this planet. It's the ultimate currency. I just picked up these pieces of paper, but let's do a different exercise with paper. I have a room filled with people. They're filling out forms. Each individual form takes 15 minutes to complete. So, in this case, I could get a throughput of 120 forms per hour written. So this seems pretty cool, right? But if you don't know how many people are filling in these forms, you guess, well, it's a single person filling in 120 forms in an hour. No, it's actually 30 workers doing that work. But the latency of the individual form is 15 minutes. So do you want to wait 15 minutes, or do you want to reduce the time it takes to fill out a single form? So then with the same amount of people, you can get a higher throughput of work performed in that hour. So the stack of paper again. It's pretty cool, but if I need to start moving these individual papers, if I put one here, and another one, and another one, and then I need to start moving the individual papers from A to B instead of the stack, that will take quite some time because I need to pick it up, need to walk somewhere else, store it, go back again, and fetch it. I cannot pick up two at the same time because I'm a single guy doing the work here. You get my point. I need to keep walking and going back and forward, picking up objects, picking up files, and getting it from A to B. The big box would be a tarball, a zip file, pretty easy, but if you want to look at the contents within that tarball, you need to extract it, and then it takes time again. Again, time is the ultimate currency. So bandwidth versus latency, you can have a race car with the content within that car is not that much. There's way more content of data stored in the truck, but the truck is slower. Huge amount of bandwidth, but it takes a very long time for the truck to arrive. And that's what we experience as users. We can put it in a table. So if we talk about IOPS, I take a queue depth of 1, let's say 1 thread. So me, single person, getting pieces of paper from A to B. The latency of 1 millisecond, that means I can do 1,000 IOPS with 1 second because input-output operations per second. If I have a queue depth or 1,000 threads running, each with a latency of 1,000 milliseconds, I still get 1,000 IOPS. So if you just look at IOPS, what do you know? You don't know anything. You need to know more stuff before you can actually make a judgment if it's a good performance or not. So, because I was just picking up papers on my own, if we would all pick up a paper and go from A to B, the amount of IOPS or throughput would be immense. But the time it will take for an individual paper would probably still be the same, or we would even be congesting here around the table, so it might even take longer. So it is all about the IOPS. And whenever somebody tells you, I got 1 million IOPS, well, then you need to ask him, okay, what was the block size? What was the queue depth? Was it read or was it write? And what was the latency for a single I/O? Often, if you look at any benchmarks of commercial vendors, and in my role as CTO at the group, I get storage appliances, they're trying to sell them to me. Usually never works because we go for Ceph, but let's say they do. And they say, we can do 1 million IOPS. That's okay, fair enough, fair enough. What was your queue depth? What was your block size? Was it read or write? And then suddenly the salesperson like, I don't know, it does 1 million IOPS, yeah, but I want to know what kind of IOPS it does. So 2 million IOPS sounds very cool, but whenever people start talking about IOPS, how did they get to the figure? I only test write benchmarks. Queue depth of 1, block size of 4K. That's what I always test on any storage system, because that really tells you a lot about the performance of the latency the system can achieve for a single I/O. Back in 2019, because this was an old slide I still had, it was pretty easy. I did this test at Cephalacon 2019 in Barcelona, and I could achieve a latency of 0.7 seconds, so 0.7 milliseconds of latency for a single 4K write. So writing that block through RADOS to the OSD, being replicated to the other OSDs, it was done in 0.7 milliseconds. So if you divide a second by that latency, you get to 1292 IOPS. The bandwidth in this case was 4.2 megabytes per second, because we were testing with 4K blocks. Multiply the amount of IOPS by 4K, you get to 5.2 megabytes per second. It's not sexy, I know. It's just 5.2 megabytes per second, and we're talking about just 1,200 IOPS. But it gives you a lot of the fundamentals, because this Ceph cluster could probably do 100,000 IOPS, or maybe even more, but we would not know the latency of the individual I/O. Scaling out Ceph and getting a lot of IOPS is just adding a lot of OSDs. Just horizontally scaling, just adding more and more OSDs, increasing the queue depth, and you'll get to high numbers with a lot of IOPS. But again, it doesn't tell you anything about the latency of the IOP. And I think that single-thread latency is the most important thing. I am biased. I come from the hosting industry, where we are tasked with millions and millions. So I talk about probably usually towards 1 billion of small files and systems. Anybody has ever used rsync? Waiting for rsync in the middle of the night, finding changes. That's latency. That's just rsync scanning over the file system, talking to your other peer, trying to detect the changes. This morning, I saw the talk from Daisy here, where they moved the home directories to CephFS. I'm quite interested to see how Restic will keep up with the latency over time. We're trying to find the differences on CephFS and actually do those backups, because that's not about bandwidth, that's about latency. How fast can CephFS actually tell you? You can detect the changes between your previous backup and then actually start doing the backup. Latency, latency, latency. So waiting for that insert in a SQL database, that's determined by latency, not by bandwidth. Achieving a low latency is not easy nor cheap. A SQL insert. I just made a very small table on a database somewhere, and I inserted that we have a new Ceph event. But your storage latency determines how long it takes for this individual SQL transaction to commit. And what are usually users waiting for is for this transaction in the database to complete before they can go to the next page on an application, or the application or the phone responding, an API giving back a response. It is waiting on this database. And if the database is experiencing a high latency, that means that the whole chain afterwards just becomes slower and slower, and user experience starts to drop. People start to nag about it because the application feels slow. And this is just a few bytes being inserted into a table. So why do we care about performance? Because again, it's users who are using applications. If I click this button, I want it to move immediately between slides. If that takes a bit of time before, that's when we start getting annoyed. There's research out there that says every 100 milliseconds of latency is something we as humans already notice. But even if you add on 100 milliseconds of latency to a web shop where we are browsing through images, if you reduce the latency by 100 milliseconds, your conversion will go up by 4% on that web shop. Because we as humans just like having low latency. Having a phone conversation with somebody who is on the other side of the planet, and you talk, and then you start talking to each other because there's latency there. We are annoyed about latency, but we often do not focus on it. So yeah, everything benefits from a lower latency. So what can you do with Ceph? Well, accept the fact that we're replicating over a network. I saw from Surf, they gave the presentation within Amsterdam that they have this object storage with low latency. Well, yeah, still 13 kilometers of distance to travel over a fiber, which takes a bit of time. For object storage, I think it is fine. But if you would run around a SQL database on that with RBD, which needs to do an insert, you will start suffering from latency. And so accept the fact that Ceph takes time. It is a brilliant piece of software, and I've never lost any data because consistency is the most important thing for Ceph, but that's also where a bit of the latency comes from because it wants to be so consistent. You will get an acknowledgement from Ceph when the data is written to all the replicas, which is usually 3 times replication. Got me thinking, by the way, this morning, is anybody using something more than 3x replication, 4 or 5? Production or? That's for metadata. For metadata, okay. Okay, yeah, well, it just got me one. I think everybody runs with 3x. Who runs 2x? Daredevils. Yeah. Living on the edge, living on the edge. Okay, so, but there are many applications which can do their own replication. A MariaDB Galera cluster, running it on top of Ceph doesn't make a lot of sense. Let the database handle it. Otherwise, you're replicating over and over and over. The same goes for a Redis environment. Of course, it's very easy to run a SQL database within a VM on Ceph and just spawn it somewhere else, but you do need to accept that if you want to have the high-performance SQL databases, that Ceph is probably not the best place to run it. And a lot of things influence the latency of Ceph. So the storage, NVMe, HDD, must say that the type of NVMe you choose doesn't matter that much because most of the latency, if you switch away from HDD, is not within the storage device itself, it is within the OSD. The CPU clock speed, the single core performance of Ceph, the higher the clock speed is, and don't go crazy on buying the most expensive CPUs, by the way, but the higher the clock speed is, the more work can be done in a single clock cycle, so the lower the latency will be for that I/O coming in towards the OSD. Single core performance, clock speed, network, as I just mentioned, do not stretch over longer distances. Well, you can, but you will pay the penalty of the speed of light. It will take more time for that data to travel to a different location. And you do not need 100 gig per Ceph node. Theoretically, yes, if you have 10 NVMEs, 20 NVMEs within a single box, they could saturate 100 gigs. If you just tune down your recovery a bit, you're all good. Don't spend your money on so expensive network equipment, just buy a few more boxes. That's what I would recommend. Go for 25 gig, just buy a few more boxes. You get more capacity, more performance, everything more resilience. Do not go crazy on the network, but test and benchmark. Test and benchmark. So, do you need a Formula 1 car, or do you want one? That's what I meant with the network. You can go buy the most expensive stuff to try to achieve the lowest latency as possible. If that works for your use case, that is fine, but you should benchmark. Do you need one or do you want one? And in the end, I would always think benchmarking should be done on the end user experience. How are they experiencing the system they are using? If you can live with a higher latency, the users are okay with it, that is fine. If you run applications which are latency sensitive, then look at latency. Storage is cheap, I/O is expensive, very expensive. And writing data is even more expensive. And I made this joke earlier. I think that we should give most developers a spinning disk in their laptop again, instead of NVMEs. Yep. And put them on a Deutsche Bahn train. Yeah. I was on a Deutsche Bahn train yesterday coming here. But they are, sorry, this is not to say something negative about developers. Nowadays, we're so used to having an NVMe in our laptop. So applications being built by developers, they are just used to having almost zero latency because it just works on their laptop immediately. They spin up Docker containers and it just works. And then it goes to production. Oh, this is slow. Yeah, I know. We should know, I think we all know, but we should teach other people that writing data to a disk is the most expensive thing you can do. And you cannot scale IOPS that easily. You simply cannot scale. And if you, inside a single VM, trying to run more IOs on a single disk, usually doesn't work. You need to start attaching multiple disks or spread out the workload over multiple VMs. It becomes very difficult. But they're just writing a lot of data to disk, and why do you need to write it? And group it, write it at once, make it easier. A bit more focus on the application side, and we can save IO. Again, storage is cheap, you can buy very big spinning disks, no problem capacity, but latency, the biggest problem. So, benchmarking. I did a benchmark last year, I didn't see any really need to do a benchmark again. With AMD Epic, fairly simple boxes from Supermicro, I think, or Dell's in this case. I got them from a supplier in the Netherlands. So Ceph 18, block size 4K, I/O depth of 1, and for 60 seconds and just writing to RBD. So, tuning, don't go crazy, don't go crazy. I think most defaults are just fine. And I'm going to give you one example why you should not tune. Years ago, I got a call from a company somewhere in the north of Europe, and they said, we have a big problem, our Ceph environment is down. I said, okay, fair enough. Can you give me remote access, and I'll take a look at it? No, not possible. We need to get into an airplane straight away to get here because we are in health, Medicare, anything, need to go over. I said, well, okay, luckily my agenda is empty. I can fly over tonight, so I'll take the first plane to come to visit you. So I flew over, and the next morning I got in, and I looked at our Ceph.conf. There was no the central config just, and I saw these config options, and I had no idea what they did. I just simply never saw them before. So I started Googling for these Ceph options, and I found a blog post or a mailing list post where somebody said, hey, I found this configuration and it gives me a great performance. And it was a copy-paste from that mailing list post to this configuration environment. But what happened over time, these config options, he changed them, but the defaults changed afterwards again, so they upgraded over time. So they were using a config option which was relevant for the older version, but the newer version was suffering from those config options. So don't try to outsmart most of the developers because they probably know why they set a certain default, or if you think the default should change, go to the mailing list, go to community, or send a pull request saying, hey, we need to change the default. But having a very long configuration file, it will bite you over time when you start doing major upgrades. So only change what's really, really, really needed. So I tested with 3x replication, and I set the kernel option, the C state to 1, to pin the C state in 1. Anybody not familiar with C states of CPUs? Or who is familiar with the C states? Okay, so the C state 1 means that the CPU is as awake and as active as possible. If you do not set this setting, the kernel will tune down the CPU pretty quickly down to C state 5 and 6, which is almost sleeping for the CPU. If you then also set the frequency, if the frequency is set to power safe, it will take a bit of time for the CPU to wake up. And that's what you will notice with your IOs. If you then do a few benchmarking, you'll see that your IO, your latency keeps jumping up and down, up and down, up and down overall. And that's why you need to test with a Q depth of 1, because that's only when you see it. If you pin to a C state of 1, the CPU is alive as possible, the frequency pinned to the highest frequency, and then you will notice you will get the lowest latency. There's a penalty, power. You will simply consume more power with these machines. Trade-off you need to make yourself. But it is possible by pinning a CPU state to 1. So going for a lot of cores only makes sense for Ceph, for OSDs. If you want to do a lot of parallel work, but reducing the latency, you will benefit from a higher clock speed than actually adding more cores to the system. Latency, I need to press twice. Very simple test system, 3 nodes, 2 OSDs, and the results, because this is all what you came for as well, right? Back in 2019, Ceph version 14, running on Ubuntu, and we switched from an older AMD EPYC to a newer AMD EPYC, still using Samsung SSDs. Latency dropped to 419 instead of 772. And I actually think this was not to do with Ceph, this was simply that the AMD EPYC is faster. If you look at the changes which were done between 2019 and 2024 in Ceph, yes, improvements were made, but the fundamentals and how the OSD works are still pretty much the same as they were in 2019. I did a few tests with logging, everything disabled, but it made a very small difference. I could not really determine if that was the real difference in the environment. So we could see that we would jump from 1,295 IOPS to 2,386 IOPS being done. Well, that's quite an improvement to be done within a single second of work. And this is what you notice in your applications. It's what application gets snappier and better. But that's probably due to hardware just getting faster instead of Ceph improving. And before I go to these famous last words, of course, there's the Crimson work going on, the Crimson OSD, which will be replacing the existing OSD over time. Yes, that is great, with C-Store behind it, which will be optimized for NVMe, But the latency of network and of TCP and everything will still be there. The CPU still needs to act on those things. And if I look at Crimson and the changes, it will probably be a great result, but it's still network replication, data being replicated over the network, which will take time, and you simply need to accept the fact that there will be latency. So indeed, my famous last words here, you don't need 100 gig per node. Focus on write IOs, because writes are expensive, reads can be cached. If you run a VM, just give it a bit more memory, it would just do the page cache within the VM and cache all the data in there, but writing data takes time, and it's latency which users experience. If you hit somewhere a button, it just needs to work immediately. That's what we want. Remember, IO is expensive and storage is cheap. So, thank you. I see a question. I can repeat the question or you give the microphone.
In the context of benchmarking Ceph, I have never really understood the concept of queue depth. So as far as my understanding, this is kind of the caching. So when you are sending many requests to the storage to Ceph, you're kind of caching maybe 5 requests. This is the queue depth of 5. But then you linked it with a number of OSTs, and that's where I missed my understanding.
Okay, well, so the queue depth in FIO in this case is just how much work is doing in parallel. So we're just sending one IO at a time, and we're waiting for the IO to finish, and then, and it could be that the next IO goes to a different OSD, because that's how the PGs, and of course it chooses a different object name, so it probably goes to a different OSD, but that's the queue depth. So the queue depth within the OSD or within Ceph might be different. In this case, it was in FIO. So the amount of parallel threads, which is 1, so only one thread doing benchmarking at the same time.
So this means when you have multiple OSDs, you have higher queue depth because you are doing multiple...
If you scale out horizontally with more and more OSDs, you can do more work in parallel, but it doesn't mean per se that the individual latency of that IO goes down. So each individual IO could still have a latency of a millisecond, but you could be performing 1,000 at the same time. By just scaling out with more OSD. So that's also a challenge if you say, I'm going to use bigger NVMEs, or I'm going to slice the size of my NVMEs in half and simply spawn more OSDs. You'll get more parallel work, more PGs, more work to be done at the same time, but the individual performance doesn't go down. But this is really great for a multi-tenant environment where you run a lot of VMs which are doing parallel work on that environment. Within a VM, I could recommend to run IO-ping, a very simple yum install IO-ping or apt install IO-ping, and just write 4K blocks to the disk and see how long it takes.
Thank you very much.
Hi, I have a question in the context of NVMEs. If you are using NVMEs for a long time, or if you perform an enormous amount of operations on an NVMe, the performance is getting degrades over the time.
Yeah, this has happened with certain NVMEs, usually on the lower end side, on the consumer market NVMEs. With the Samsung and Intels, I haven't really seen that happening. There were a few glitches where we saw NVMEs dying. We just swapped them out because the individual latency of that OSD went up, but they were just watching Ceph OSD perf and seeing what the latency of the OSD was.
On classic servers, when I mount a file system, I can execute a fstrim command, which performs discards on the NVMe and cleanups the structures on the disk. With BlueStore, you don't have that. I discovered that at BlueStore there's the bdef discard option to use that, but I have no idea if it's a good idea to use it or,
as far as I know,
to enable it.
The bdef discard is automatically enabled if it's an NVMe device. So if it detects if it's an NVMe device, then it starts sending discards downstream. And if you make sure that your VMs running on top also issue discards towards librd sensitive to Rados, then it's propagated down towards the storage device. Yeah.
Okay, thank you very much.
To stay on the NVMe topic, do you have any experience or metrics or performance tests regarding to vendor side optimizing NVMe performance stuff like
No, it would be
optimized, mixed write, blah blah blah? Is there any?
At some point, I simply wanted to have Intel-free machines because I was on Team AMD. So that's when I switched to Samsung NVMEs, and I think that was mainly the thing. But we use a mixture nowadays of Micron and Samsung NVMEs. It really depends on which of the companies we have. But I don't have any specific performance characteristics about different vendors. What I do think is that the difference between those vendors will be so small, you will not notice them with Ceph because the latency is within the OSD, not on the storage device, if you're running NVMEs.
Okay, so I can say if the disk is mixed write and read optimized when I'm on a good track, or
I would
or it depends.
still would buy the enterprise as NVMEs because you need the power loss protection, everything. But I would go for the mixed NVMEs and simply buy more of them.
Yeah, okay. Yeah, makes sense. Okay.
All right.
Okay.
So one last question.
One last
we
question.
have.
Okay.
I wonder why you're focusing exclusively on write tests. Because in my experience, when a vendor tries to sell something, oh, we have lots of IOPS and low latency, then I go and read cold data from it. Small items, small 4K blocks of data, which is cold, randomized over the thing, and then I see it's not that cool as they want to sell it.
No, of course, the reason why I focus on write is what you will see in most applications, that reads can be cached by the application itself. So if you run a SQL database on top of Ceph, the database probably will be living in memory of the database server. So trying to do a select on the database is almost instant because it lives in memory. Yes, on a cold start, if you had a power outage in a DC, everything comes up again. It will take a few hours for the memory to populate and everything. But the write will always suffer from the latency. So that's why I always test writes first with Ceph. And if you use object storage, you can do some caching in the RGW, or if you have some public objects, you can put varnish in front to do caching. That's all pretty easy to mitigate with memory, but writes, you cannot cheat. It has to be written to the disk, and that's what takes time.
Okay, thanks.
That was a good word at the end. Right, you cannot cheat. Yeah, thank you, Wido and Hollander, for being here on stage. Thank you very much.